U prošloj epizodi predstavili smo vam ICGB, Međunarodni centar za genetički inženjering i biotehnologiju, koji ima 45 najsavremenije opremljenih laboratorija u Trstu, New Delhiju i Cape Townu i okuplja 69 zemalja sveta, uključujući i Srbiju. Pokazali smo kako nastaju biofarmaceutici, lekovi koji se ne prave klasičnim hemijskim putem, već biotehnološkim metodama. Imaju ista dejstva kao obični lekovi, ali su jeftiniji za proizvodnju i zato dostupniji zemljama u razvoju. Istakli smo značaj međunarodnog udruživanja i deljenja naučnih znanja. A ICGB je samo jedna od brojnih naučnih institucija smeštenih u Area naučnom parku, zbog koga Trst nazivaju gradom nauke i inovacija. Area u Trstu je jedan od najrazvijenijih naučno-tehnoloških parkova ne samo u Italiji, već i u Evropi. To je mesto susreta akademske zajednice, naučnih centara i visokotehnoloških kompanija. Prostire se na 80.000 kvadratnih metara i sastoji se od 2 kampusa i okuplja nešto manje od 60 nacionalnih i internacionalnih kompanija i instituta.
We are actually a complex system. We like to call us an ecosystem, just meaning the fact that we are made of several pieces, but what counts is the relationship between these pieces, which really makes the ecosystem or the need of every part to make the whole. It was created 46 years ago with a special law, and it was based in this territory with very specific aims, which were the mission that was to create a system where the transfer of knowledge could be very well organized and implemented. Until 1954, Trieste was not Italy. It was, as an effect of the Second World War, it was divided into 2 sectors. And when almost 25 years later, when the center was created, it had also the meaning of supporting the local territories from the economic point of view. The Science and Technology Park was an environment where research and industries, enterprises could work together, close contact, in order to make this region, this local economy, grow and improve the performances of this area.
Area naučni park osnovan je 1978. godine kao centar izvrsnosti u oblasti istraživanja, inovacija i transfera tehnologije. Danas razvija snažne veze između nacionalnih i međunarodnih istraživačkih centara i kompanija koje se bave prirodnim naukama, inovativnim materijalima, informaciono-komunikacijnim tehnologijama i zaštitom životne sredine. Od osnivanja njegov cilj ostaje nepromenjen, da naučna istraživanja i visokotehnološka infrastruktura postanu pokretač ekonomskog razvoja i društvenog napretka.
Naši stanari su i kompanije i naučno-istraživački centri. Ono što je jako bitno, da bi mogli da budu stanari, moraju da imaju R&D projekte. Znači da se bave istraživanjem i da imaju inovacije. Znači to je jedan od preduslova da bi mogli da budu u samom parku. Od kompanija imamo start-upove, mala, srednja i velika preduzeća. Ono što je jako fino za park jeste da neki od njih su baš rođeni u samom parku. Znači jedna od njih je, na primjer, kompanija, bivši start-up spin-off univerziteta u Trstu, Pikosat, na primjer, koji je uveo revoluciju u malim satelitima. Pored njih ima i Aindo, koji razvijaju platforme, software platforme sa upotrebom vještačke inteligencije, ali njihova primjena je moguća u svim sektorima, od zdravstva do logistike, do financija. Znači, kao što možete da vidite, ima dosta različitih aktivnosti u svim sektorima u kojim se nalazimo. Imamo 7 naučno-istraživačkih centara, elektrosiklotrone. To je jedna svjetsko priznati institucija koja sa sinkrotronskim svjetlom istražuje materijale na atomskom i molekularnoj razini. Ili Međunarodni centar za genetski inženjering i biotehnologiju pod UNESCO-om. Sve je to bitno. Zašto? Zato što ekosistem je taj gdje mi uz pomoć upravo tog odnosa svakodnevnih aktivnosti i bliskog odnosa sa našim stanarima i sa kompanijama pratimo njihove R&D projekte i onda pokušavamo da ih usmjerimo u nešto što možda u njima u tom trenutku je potrebno, a što neki drugi stanar ima.
U središtu delovanja area naučnog parka su visoko specijalizovana istraživanja, razvoj održivog modela upravljanja ovim velikim ekosistemom, kao i podsticaj unapređenju novih modaliteta inovacija.
Innovation is not just an incremental process where you improve things from something that you already have. This is the simplest way of looking at innovation. Since we have the research centers, we believe that innovation can be also disruptive. This means that if we start from the ideas that a researcher can have, and we are able to support him or to support the startup during the process, we can, in principle, land to this field of, we call it not way, but it's called disruptive innovation that is related to research, that is new ideas that can really change the society and the way in which some things are have an impact in our lives, which means that we are moving from a role of the park that was the enabler of the technology transfer, the knowledge transfer. We moved to being the producer the direct producer of knowledge. I mean, we invested a lot in research infrastructures and technological infrastructures. What makes the difference is really this concept of making the access to high-tech laboratories, to innovative technologies open to enterprises and communities and scientists who deserve it.
Ilustrativni primer naučno-istraživačke infrastrukture koja se razvija u area naučnom parku su 2 velika istraživačka postrojenja za ispitivanje materijala pomoću svetlosti. To su akceleratorski prsten Elektra i laser slobodnih elektrona Fermi. Oni omogućavaju dobijanje svetlosti određene boje i kvaliteta na više od 30 eksperimentalnih stanica, što omogućava proučavanje strukture i funkcije materije sa osetljivošću do molekularnog i atomskog nivoa.
In very simple words, we can define electron like a microscope. So essentially, the synchrotron electron is a machine that produces light, and this light is used for investigating the materials. So which type of materials? Any type, biomaterials, hard materials, or surfaces, for example. The light produced by electron has a very special characteristics. It is billions of times more brilliant with respect to ordinary sources that we can find in conventional laboratories. And so this gives us the possibility to show up details that are invisible for many other techniques.
Ova istraživanja imaju široku primenu. U medicini omogućavaju proučavanje strukture molekula povezanih s razvojem bolesti. U energetici se ispituju novi materijali za skladištenje i proizvodnju energije iz obnovljivih izvora. U oblasti zaštite životne sredine otkrivaju se zagađivači u zemljištu i vodi kao i njihov uticaj na žive organizme i tako redom. Već 3 decenije sinhrotron Eletra stoji u službi nauke. Sada je došlo vreme za novu fazu razvoja, izgradnju Elektre 2.0. Tokom naše kratke posete prisustvovali smo dopremanju nove opreme kojeg će akcelerator unaprediti u savremeniji i snažniji sistem budućnosti.
Now is the time for a very big challenge. And the challenge is to rebuild this machine and toward something that is called fourth generation source. So which are the characteristics of this source? This source will be even more brilliant with respect to the present one, and it will be more coherent. What does it mean coherent? It means more similar to a laser, but still having a very broad emission range from the infrared up to the hard X-rays. So essentially, in very few words, what we can do with the new machine in the future is to do faster measurements, to be more sensitive. What does it mean sensitive? It means that we can trace or detect elements at a very minute concentration in the samples, for example. And we can also monitor things lively. So essentially, what is going on that we are moving for a system that is just picturing or photographing a phenomenon to something that is filming it. So in order to see things in movement and processes developing. We are going to close the machine in July 2025, and it is expected that the light will be up again in the beginning of 2027, and we hope, obviously, that will be useful for the scientific community as long as possible, and possibly for other 30 years in the future.
Velika ulaganja u tehnološki savremeniju infrastrukturu otvorit će vrata novoj vrsti istraživanja. Visoko profesionalni tim hemičara, fizičara, inženjera i ljudi specijalizovanih za optiku posvećeni su konstruisanju i testiranju magneta koji će biti implementirani u novi sistem.
These magnetic devices, they are needed in order to essentially bend the electrons that run in the machine, and those are exactly those electrons that are running. When they bend, they produce the light that we call synchrotron light. So the Elektra 2.0 will be a machine very different from the present Elektra, exactly for this magnetic structure that will be much more performant, and then will allow us to have these characteristics, these improvements that I already told before.
Sinhrotronski izvor svetlosti Eletra i laserski izvor slobodnih elektrona Fermi su 2 komplementarna izvora svetlosti koji funkcionišu u okviru istog istraživačkog centra Sinhrotron Eletra u Trstu. Šta je Fermi, iz čega se sastoji i po čemu se razlikuje od Eletre, objašnjeno nam je kroz slikovit primer.
You're a scientist and you want to examine a flying bee. Your eye can see clearly the bee during the flight, but your eye can't see the wings moving. So you can imagine the synchrotron, it's your eye. So the synchrotron can monitor, can see the bee, but the synchrotron can't see the wings moving. The free electron laser indeed is able to see the wings moving. So this is the main differences. The free electron laser Fermi can resolve the ultra-fast dynamics in matter. So that means that the free electron laser can see electrons moving, atoms moving, while the synchrotron has other peculiarities, characteristics, and Elektra and Fermi in this sense are complementary.
Dakle, Fermi omogućava proučavanje ponašanja materije pri izuzetno brzim procesima u realnom vremenu. Tada se koristi laser slobodnih elektrona koji omogućava da se vidi kako se elektroni kreću i kako atomi vibriraju unutar materije.
Fermi can deliver ultra-short pulses of light, very, very short. So it's like when you go to the disco and you see the dancer illuminated by a stroboscopic light. These ultra-short pulses delivered by Fermi illuminate atoms, molecules, just for a while, and you see them freeze, like a dancer under a stroboscopic light in a disco. So the secret is to deliver very short flash of light, and this is what Fermi can do. But be careful, this light is not visible. It's on another range that is not visible by our eye, but is very interesting for scientists. It's something close to the X-rays, okay? So very, very short pulses of soft X-ray light that illuminates materials, molecules, devices, and are able to see atoms in those materials moving, electrons in those material movies, and so on, like the wings of a bee. Now we are in the experimental hall, so 300 meters far from here, there is the accelerating part of the free electron laser. What we accelerate electrons. So free electron laser means that we have bunches of electrons traveling along a very long section, accelerated to very high speed, close to the light speed. And after this acceleration, these electrons are, manipulated in order to generate light. And we get that light here in the experimental hall, 300 meters downstream of the accelerating session, and we use that light to carry out experiments.
A eksperimenti su sasvim različiti. Od analize kretanja elektrona u fotonaponskom materijalu do analize atomskih mehanizama u memoriji računara. Suštinski, Fermi prati dinamiku i detalje fizičkih pojava koje su u osnovi mnogih procesa.
Currently, we are attempting for the first time a very specific experiment on a superconducting material. And yes, it's the first time that we are trying to do this kind of experiment, and we are very excited about that, I must confess. For the moment, yes, the preliminary data seems to be promising, yes. Let's see. The experiment is ongoing now. It's very difficult to study superconductivity material because, as you know, the temperatures you need to generate superconductivity is very, very low. So you have to cool a lot the sample, and do this is complicated. And then we add also a very complicated machine. We add also a very complicated optical setup. Therefore, it's really a frontier experiment.
Još jedna najsavremenija opremljena laboratorija u okviru areja naučnog parka, otvorena 2022. godine, je LAME, laboratorija za elektronsku mikroskopiju. Radi u bliskoj sinergiji sa izvorima svetlosti, elektra i Fermi, omogućavajući integrisane naučne analize koje se mogu sprovoditi na svega nekoliko mesta u Evropi. Ova laboratorija otvorena je za istraživače iz akademske zajednice i industrije u skladu sa najvišim evropskim standardima.
I will give you an example on the reason why our instrument is so performing and important to address material science problems. This is a transmission electron microscope, a 200 kilovolt transmission electron microscope from GOL with a cold fax source, which means a high brilliance source. The principles of this TM is that electrons are accelerated from the top of the source, from the top of the column, and they are forced by an ensemble of lenses and magnetic field to travel to the columns to reach the specimen area. Here the specimen is placed and is pre-prepared in such a way to be electron transparent, which means make it thin down to 10 nanometers. In such a way, the electrons can go through the specimen and be collected below, and all the information coming from the interaction between the electrons and the specimen can give us the opportunity to produce images bringing different informations. Here, for instance, you can see an example of a high-resolution image of a thin film which is relevant for microelectronics. And the way the image appears gives you already a lot of information. For instance, you can see these small dots, which are atoms, because we can really reach atomic resolution with this microscope. And with this image, you can have the opportunity to see if the atomic organization in a material, which is, for instance, relevant for device applications, is organized in such a way to be coherent with the applications and with the functional properties of the material that are expected from that material. If not, transmission electron microscopy provides you the opportunity to optimize the material. So it's a sort of loop, of a virtuous loop that you build with other researchers in order to have this value chain of improvement. Together with this, you can perform a chemical analysis, so you can see which are the elements, the chemical elements which are composing our sample. So there are many different information that you can get just with one tabletop equipment, which provides you with a unique platform to study materials. The full equipment, consisting also of the advanced analytical capabilities that we put in this machine, is about 2.5 million. Overall. All what I said can be done with this microscope, but we will push our limits even further with the new microscope that we are going to acquire and which will be delivered in this fall, which will provide us with the opportunity to reach a sub-angstrom resolution, to push even further the limit of atomic resolution and to have information which are cleaned out by the spherical aberration, which is an inherent factor of these microscopes, which is removed in the high-end machines.
Laboratorija Lame, kao i ostali istraživački kapaciteti area naučnog parka, ima za cilj da omogući otvoren pristup svojoj opremi i resursima naučnicima iz akademske i industrijske zajednice, kako iz Italije, tako i iz Evrope, pružajući podršku najkvalitetnijim istraživačkim projektima i idejama. Nas je zanimalo kakve se sve mogućnosti otvaraju za Srbiju.
In November, we hosted a bilateral colloquium between our and your research minister, and I discussed several possible cooperation thematics, areas. And for example, in this specific case of microscopy, if the project gets into the European roadmap, and then which means possibility to access European funds, other countries can join. This is because the concept of the research infrastructure, that's why I'm insisting so much on that, is that it's an open system. So in every moment, another country can join. The important thing is that you join because you bring in expertise, you bring in your human resources, laboratories, facilities that you have, and you can contribute and get contributed.
Pored međudržavnih sporazuma i institucionalne saradnje, Area Naučni park pruža brojne prilike za individualno uključivanje mladih istraživača.
Most recently, we decided to start a specific action to have a better involvement of students from, in general, Western Balkans and specifically also from Serbia. So we organized specific bilateral meetings also with the ministry following the research in your country, Serbian ministry dealing with the research. And the last one was in 2023, if I remember. And also outreach events with the scientific community, for the moment mostly in Belgrade. We were hosted by Belgrade University twice and by the Institute of physics in Belgrade as well. And so our proposal from the Elettra side, I mean, was to try to create a specific program. For the moment, it's a pilot action, a few numbers, I mean, but it's just a starting point for training in education for students, which means doctoral studies for university, following university studies, in connection with local, I mean, Serbian universities.
Area Science Park nudi mogućnosti stipendija, pošto jako se dosta radi na jačanju mladih talenata. Naprimjer, stipendije svake godine Area Science Park kompanijama koje su u samom parku stavlja na raspolaganje 15 stipendija, gdje se daje mogućnost znači, mladim studentima i mladim istraživačima koji mogu biti i naravno na području Italije, ali ne moraju biti, da kažem, nije samo namijenjeno Italijanima, koji mogu onda zajedno sa kompanijom da razvijaju projekte i znači, rade na svojim kompetencijama i imaju mogućnost pristupa i kompanijama.
Na kraju, tu su i pozivi za mlade istraživače koji još uvek tragaju za svojim pravim naučnim putem koji mogu otkriti baš ovde u Trstu.
Let me add that young people, young scientists are necessary here in a place like Fermi. We need motivated young scientists. This is essential because frontier research requires new ideas, new energy. Sometimes young scientists think that they can't do this because it's too much difficult. This is not true. I've been working here for 15 years and I'm still learning how to carry out experiments. So it's a very long path. Nobody knows how to carry out this kind of experiments in detail. Every time you can improve. So my message is, come here if you want. Let's try. We continuously open positions at Fermi, postdoctoral positions for young scientists. Let's try to participate in the selections. It's important to us to have young scientists.
Priči o Area naučnom parku nema kraja. U narednoj emisiji otkrivamo jedan od njegovih važnih resursa, veliki data centar posvećen istraživanjima u oblasti veštačke inteligencije i nauke o podacima. Pored toga, odvešćemo vas u čuvenu školu za napredne studije, SISA, koja je namenjena isključivo doktorskim i postdoktorskim istraživanjima u oblastima fizike, matematike i neuronauka, koju pohađaju i naši studenti. Stigli smo do kraja današnje emisije, ali se naša priča o Trstu, gradu nauke i inovacija ovde ne završava. Budite sa nama i sledeće nedelje.